All right, welcome. This is going to be TRiRODS for, what month are we in? August of 2021. And we've got two speakers today, so we'll break these into two different videos. Our first speaker is one of our summer interns, Gabrielle Maxwell, and she's going to talk about the work she did on the Python tool, the ingest tool for refactoring it. Switch the camera.
So to recap, my name is Gabrielle Maxwell, and I'm an intern for summer of 2021 with iRODS, and I worked on the ingest refactor. So basic overview of what I'm going to cover in my presentation is some introductions. I have a basic introduction about myself and the tool and the project in general, and then I'm going to move on to getting started and the challenges that were faced while working on the project. Then I'll talk basically about the technologies that were used, and then move into the design, implementation, and testing. Then I have a demo, which I'll cover both the refactored version and the original version of the automated ingest tool with the S3 resource plugin. And then I'll talk about some lessons learned and the key takeaways from the summer. So basic about me, I'm a recent graduate from Appalachian State University, and I got my bachelor's of science in computer science. I have a cat named Edamame, and in my free time, I enjoy hiking and doing outdoor activities. I heard about the internship through AppHack, which is App State's annual hackathon, of which I was on the board of directors for. So a basic overview of what is the iRODS Automated Ingest tool. So the tool provides a flexible and highly scalable mechanism for data ingest, and it solves two major use cases, which is getting existing data under management and then ingest incoming data hitting a landing zone. And the tool is implemented with the Python iRODS client. So for the project overview, so currently the iRODS automated ingest tool can scan in parallel a local file system and an S3 bucket for new and updated files. And my main goal for the summer was to work towards refactoring the tool so that's easier to understand the code base and general flow of logic, and making it more extensible so it's easier to add new scanner types in the future. So some of the challenges faced while getting started was, I feel like iRODS has a pretty high learning curve. So before beginning the project, I needed to form some sort of base level of understanding of iRODS. And to work towards this, I completed the iRODS beginner training. And then after that, I needed to get the tool to work in my development environment. And I used my personal machine, which runs Ubuntu 18.04. Then the next step was understanding the ingest tool on a more fundamental level. To do that, I followed along with the UGM 2019 automated ingest presentation and got help from the iRODS team. So with technologies used, they're both new and old. Some of the new things I had never been exposed to before was iRODS itself. I didn't have any exposure until this summer or understanding of iRODS. And Redis, I had also never used before, which is an open source data structure, and Celery, which is also open source, and it's used for asynchronous task and job queues. Older things that I hadn't been exposed to before was Python. I used a lot of Python in my classes at App State and also in personal projects. And then Docker I had some basic understanding of from previous jobs and internships, and it's an open source software platform that is used to manage application containers. So moving on to design. So the first step was to decide which pattern would be best fit for the changes that needed to be implemented. And I got a lot of help from the iRODS team to do this, where we would have planning meetings where we discussed the different patterns and ideas behind them. And through that process, landed on the idea of kind of a hybrid of strategy and factory patterns. So as a basic overview of what strategy is, it's used to select a specific algorithm at runtime. In factory, the idea behind that is to create objects without having to specify the exact class of the object that's being created. So moving forward for implementation. So I tried multiple approaches where some worked and some did not, and I ran into a couple issues along the way, which I'll talk about in the next slide. So the main things that worked and are important to talk about would be creating a new file with scanner.py, which is used to separate out the different scanners from sync task, which is where the logic was originally housed. And most of the changes were in sync path and sync entry. And this is where you could see a lot of the differences between the different scanner types. And so now each scanner type is its own class, which contains helper functions for the differences between the types. And so, for example, each class has a helper function instantiate, which contains the specific implementation for that scanner. And I'm able to call these functions by making an object syncer with the scanner factory, which is passed the metadata and returns the correct scanner that's needed. So continuing with implementation, some of the problems faced were circular dependency, and a basic overview of what that is when multiple modules depend on one another to actually be able to function. And saw this mainly between the new scanner.py file that was created and sync task. And a solution for this, so since for the most part that Python is an interpreted language, you can import at the bottom of the file, avoiding errors where something has yet to have been created. And then in the loops, some of the differences between the scanner types were inside of loops that had conditionals, which would need to be able to return continue, or not return, but be able to continue. And so the solution for that was to create my own class called continue exception, which is inside of sync task, where I'm able to use that. So this is inside of scanner. And whenever this condition is met, it's able to raise this, and then down the line, it's back in sync task, it's able to continue where it's supposed to. So when it came to testing, it took about 2 weeks to get the tests to run properly. And this was important that they worked so that there could be confidence moving forward with the project. And then before the tests were done, or before the test worked, I did a lot of manual testing by running the tool with mock data. And when attempting to run, Celery would show me errors, which allowed me to trace through the code and solve the problems as they came up. So moving on to the demo. So first, I'm going to show the original version of the tool before the refactor. And I just need to double check that iRODS is up and running. So I can do that within ILS, which shows me previous things that I have ingested before. And then I also need to make sure that I have a Redis server up. And I can do that with this, and it responds Pong. So I know that I have a Redis server up and running. So I'm going to run Minio locally on my machine to ingest the data from. So I will quickly set that up. Okay, and as I did not set any of the default environment, or it didn't change any of the environment variables, they're still set to the default, which is just Minio admin. And then from here, I can create a bucket, and I can add data that I want to ingest. Right, now that I have that set up. So what I do have, and I already have this created, but so this is a screen snippet of that. I need a text file containing the key pair so that I'm able to pass it through later. So when it comes to the resource plugin, I just added the link to that on GitHub, and I already have this created on my machine. So this here on the left is the configuration for the S3 resource that I'm using, and on the right is the configuration to speak to iRODS. Right now, in a new window, I'm going to start Celery. And when that's up and running, I can open another new tab where I'm going to set up my RODSync virtual environment, which this is where I will be running the commands for the ingest tool from. Okay, and then the last step would just be to ingest the data. Okay, and after this runs, we should be able to see there is a demo 10. And then if I check the ingested data, I can do and from this, we'll be able to check the timestamp and see that's using the S3 resource, and the path is the S3 path. Okay, and so now I'm going to do the same thing, but with the refactored code. So I'll stop sorry real quick. And I'm going to switch branches to my refactored branch. Oops, I can't see this. And then from here, I should be able to just run pip install so that I can run the command. Or actually, sorry, I need to install it in the RODS for it to work. Okay, and now all I have to do is restart Celery. And I should be able to ingest data, and we're going to put it in demo 11. And as we can see, there's new demo 11. We can check again. And timestamp has the same file path and S3 resources what's being used. So that's good that it did the exact same thing because that was the goal. Okay, and some of the lessons learned and key takeaways from this project over the summer on an academic level, I gained understanding and experience with new technologies of which I had never been exposed to. On a professional level, I gained experience in real-world team workflow and development. And personally, I improved my critical thinking skills and overall confidence. And thank you. And do you have any questions?
Excellent.
So in your demo, I remember you mentioning the master branch had an issue with the Minio client. Is that now merged?
It's not merged. I had a separate branch created where I used cherry pick and pulled it down into it.
Okay, cool.
Yeah, and the reason that didn't work is that since we had last played with this, Minio made HTTPS the default. And it wasn't at the time, so we had to not do that.
Yeah, makes sense. Cool.
Any questions for
In
anybody?
this project, did this project also increase like the boundaries of your knowledge of Python itself?
Yeah, definitely. I feel like, yeah, overall, I've gained a lot of knowledge with all the technologies that we use.
I have a question.
Corey. Any questions?
Did we learn of any like performance bottlenecks or anything that might have been improved through the refactor?
Performance wise,
Either
that what you
performance
said?
or like, do we have better, is there better error handling or things about the refactor that, you know, that we got out of it?
I would say that's not entirely what I guess my focus was for the summer. So that's not something I would say like I put a lot of attention towards and checked.
Okay.
Yeah, I don't know if we discovered, did we discover any other shortcomings or opportunities while we were investigating? I guess not really, because
Yeah.
mostly having to reverse engineer what didn't work when we handed it to you.
Mostly having to do everything string-based with the meta variable, right? Which it pretty much describes iRODS in general.
Yeah,
String, it's a string.
it's a string.
The only thing I could say to that is it may be easier to make said performance improvements in the future, given the separation of the concerns.
Yeah,
I guess one other question too was, do we feel that it's easier to jump in and contribute to the project, given that you did go through a refactor?
You mean for the next person we hand this to?
Yeah, like code wise, like because you know I've looked at the project and you know struggled to understand what was going on.
Yeah, I would say, I think it would be easier definitely for people coming in the future, because instead of having everything kind of in big conditionals, all the logic that is somewhere between the two isn't repeated. And then from that, in the scanner.py, the things are their own class, and they have the same helper functions, just with different implementations based off of what the requirements are.
Very cool. What was the single biggest surprise? Something you didn't expect this summer?
I didn't expect.
I don't know.
Oh gosh, I don't know. Blanking on
No,
that one.
No surprises, huh? It went exactly as she planned.
Yes.
Perfect.
So what is the timeline on the iRODS scanner?
On the scanner where we point this thing back at iRODS again?
Yes, in order to scan the negative space.
Well, it should be shorter.
This was step one.
What are the named? Are there 3 things that are in each scanner? Are there 4 things? How many are in each one? How many things have to be implemented?
That was my next question, is what does the actual interface look like?
I
Yeah.
can pull it out.
Yeah, you've got it.
I suppose that's fun.
Because I imagine that 2 or 3 of them probably aren't very complicated. Probably only one that probably needs some eyeballs.
Yeah, so if we look in, this is sync task. So if I go up to sync task, see I'm making the syncer.
Yep.
Which calls scanner factory from scanner. And then down here, iter is created through that. And then if we go look inside of scanner, over here inside. So here's the file system scanner, and then inside of that, there's instantiate, iter, construct, and construct path. So 3 things.
So there's 3 things. It's an iterator, construct path. Yeah, it's really, should be pretty straightforward. Iterator is basically going to be a query, right?
Like the query iterator, maybe?
Maybe a query iterator? Is that a thing?
Ooh, that sounds pretty good.
That sounds like something we should do. Got top people on that. And the construct path is just strings, right? It's just a,
Well, for the file system.
Yeah.
scanner. Yeah, for S3.
so I don't know, maybe, what day are we on? Wednesday, maybe Thursday, Jason? How do you think?
That sounds like a good day.
Okay, all right, we'll get on that. Very good. Anything else, anybody? All right. 21 minutes, we did it. Very good. Cool.